Okay, guys, for this lesson, we're going to learn how to solve the system by the algebra method of substitution. So instead of graphing to see where the two lines cross, we're going to just use algebra to solve, again, using the substitution method. So remember that a system is two or more equations working together to find a solution. And the solution is that point of intersection. It's an ordered pair, which has an x and a y value. So we've already learned how to solve by graphing. Now let's look at solving by substitution. And then our next lesson will be solving by the elimination method. Again, let's just recall we can have one solution, infinite solutions, or no solution. Now, to solve by substitution, the most important thing that you jot in your notes is you have to make sure that at least one equation has at least one of the variables isolated. So please write this step in your notes. You do not need to solve or to write the rest of this stuff down unless you want to. But this is the main important thing when you use substitution. One of the equations has to have either the x or the y isolated. So let's just practice. So here's our example 1. And the first thing that we ask is one of the variables isolated? And we can see that in equation 1, y is isolated, so we're good to go. This is called substitution because I'm going to take what y equals, negative 4x minus 8, and I'm going to substitute it in to the other equation. So I'm going to rewrite this equation by substituting, and yes, we need parentheses. Instead of y, we're going to put what y equals, negative 4x minus 8, and that equals 3. Now, the reason that we are doing this is because now we have one type of variable. We have x's. So we can actually solve this equation to get an actual value for x, which is half of our solution. So we are going to distribute the negative 3. We're going to get positive 12x plus 24. We're going to combine our like terms and get negative 3x plus 24 equals 3. Now we're solving for x. We subtract 24 from both sides. We divide each side by negative 3. And the x value for our solution is positive 7. So when you write your solution, make sure you put it in the right spot. It's x comma y. Now, this is half of our answer, so we're going to take what x equals, which is 7, and substitute it in for either of these equations. I always like to do the one where the variable is isolated. So we're going to find out what y is. Y is negative 4 times the value of x minus 8. We're going to multiply and get negative 28 minus 8, and our y value is going to be negative 36. So these two lines on the coordinate plane cross at 7, negative 36. That would be in quadrant 4, positive, negative. So somewhere here in quadrant 4, they would intersect. Okay, let's look at example number 2. And remember, at any point you need to pause the video, do so. So when using substitution, the question is, do I have a variable isolated in either of the equations? And I actually have both y isolated in equation 1 and equation 2. So let's just say y equals 8x plus 9 and take that and substitute it in for this y here. So I'm going to say 8x plus 9 equals 7x plus 7. Again, the goal is to have one type of variable. Now remember, that when you have variables on the left and the right, we want to focus on getting the variables together first, not the constants. So I'm going to subtract out and move my 7x, and I have x plus 9 is equal to 7. Subtract 9, and my x value is -2. Now we need to find the y value to create our solution. We're going to take -2, and I'm just going to plug it in for x here. You could have plugged it in the second equation if you wanted. Either one will give us our answer. I have -16 plus 9, and my y value is going to be 7, and it is negative. So this point of intersection is going to be here in quadrant 3. It's going to crisscross somewhere in quadrant 3. Okay, go ahead and write down example 3. And our question is, do we have a variable isolated? We do not. We have the x and y together on the left, as well as in equation 2. Now, we need to decide, and we need to get one of the variables isolated. Here is what I look for, guys. I look for a variable that has a coefficient of +1. That's the first thing I look for. And we have it here. The reason I do that is because in order to isolate x, I simply have one step to do. Now I have +1x is equal to 3y plus 3. X is isolated. So now it says x equals 3y plus 3. So I'm going to take this expression of what x equals and substitute it into our first equation. So we're going to have 5 times, instead of x equals 3y plus 3 minus 3y equals -9. Now solve for y. So we're solving for y this time. We have 15y plus 15 minus 3y equals -9. We're going to combine our like terms. We're going to solve for y by subtracting 15. And now we're going to divide each side by 12. And our y value is -2. So again, be very careful to put it in the right location. So -2 is y. Now I'm going to go back to the equation and plug in -2 for y. I could have plugged it in any of these equations. X equals 3 times -2 plus 3. -6 plus 3, x equals -3. So these two lines would cross in quadrant 3, negative, negative. So somewhere here they would intersect. Okay, example 4. Our question, do we have a variable isolated? And we do. Y equals, so we're going to take this expression and substitute it in for this equation. So we have 11x plus, I don't really need parentheses because my coefficient is +1. But I'm going to go ahead, since we have a negative here, plus, and it's -x minus 4 equals 6. So this is really -x minus 4. Combine, I get 10x minus 4 equals 6. We're going to add 4 to both sides. And we're going to divide each side by 10, and our x value is 1. That goes in the first spot of our ordered pair. I'm going to take this value of x equals 1 and plug it into this equation. So I have negative x is 1 minus 4. This is negative 1 minus 4, so y equals negative 5. So on the coordinate plane, this intersection is going to be in quadrant 4. So somewhere here, these two lines would intersect. Okay, our next example, I can easily see that I should probably isolate this x because we need a variable by itself. So we're going to subtract 2y from both sides. We're going to take this expression and substitute it in for x here. We're going to distribute the 7. That gives us negative 14y minus 84 plus 4y equals negative 4. Let's combine our like terms. So we get negative 10y minus 84 equals negative 4. Add 84 to both sides. Divide by negative 10. And the y value is negative 8. Again, I want to make sure I put that in the right spot of my ordered pair. Now I'm going to plug in negative 8 for y here. X equals negative 2. Insert negative 8 for y, minus 12. I have 16 minus 12, and the x value is 4. That is the solution. One last thing, if you're solving and you have variables that cancel out and you are left with, say, like 5 equals 5, this tells me that those lines were actually the same and you would have infinite solutions. And if your variables canceled out and you ended with like 6 equals 5, this tells me that's a false statement. So this means that these were parallel lines. They had the same slope and different starting points. So there would be no solutions because the lines would never intersect. So just keep this in mind as you are solving using substitution, and hopefully this helps.